Okay, so this is a perfect example. One where we would prefer the shell method because we're revolving around the x-axis and the function is written in terms of y because it needs to be opposite. So if it was the other way, we would want to use a disk method. So we're going to use you want to use whichever method is going to be easiest for you. Let's see. So let's sketch this out so you can get a good visual of what's going on here. We're rotating around the x-axis and our function from, and this is 0 to 1 for y. That's what that means. Okay, so our function looks something like this. We're going from 0 to 1. It's going to look kind of like this. And so we're stopping there. We're rotating this way. So if we were doing the disk method, can you see right here the disk would be a steady side. It would just be a normal cylinder. And then right here the disk would be based on this equation. Since we're using the shell method, we do this in this way, and we can always use that equation. I know it's hard to understand. I'm going to try and explain that after this, but trust me, it is a little bit better. Anyhow, we're rotating around the x-axis. We're going to get these cylinders, and we're going to form a solid here. So anyhow, let's set this up. And let's do this. Volume equals 2 pi. We're going in terms, because we're rotating around the x-axis, we're going in terms of y. So as y goes from 0 to 1, the radius is going to be given by y because the radius will increase. The radius starts here and the radius of the cylinder will increase until right there. So that's just going to be y. I told you that's typically just going to be the plain variable. And then the height of the cylinder is going to be given by this value, which is this function, x equals e to the negative y squared. If we do this in terms of y, we will have our answer. All right, so let's see what happens here, because this is one that we can integrate. So we would do the derivative of negative y squared. And, okay, so if you remember, we do like a little bit of a u substitution. I'm just going to focus right here on this. Oh, du, 2y dy. Oops. Okay, anyhow, so I'm going to swap out some stuff here. So v is equal to, I'm going to take the 2, because I'm going to need a 2y. I'm going to take the 2 and move it inside. I'm also going to, so pi from 0 to 1, 2y, e negative y squared dy. And then, of course, negative y squared, this becomes u. And 2y dy, I need a negative 2y dy. So if I put a negative there, I'm going to put a negative there. And now this all becomes just du. Anyhow, eu du, this is a really simple one. Let's see, that would just be e to the u. Negative pi e to the u from 0 to 1. Let's swap the u back in. And I'm going to put the negative y squared back in. So negative pi of e to the negative y squared from 0 to 1. And now we can actually just plug that in and kind of get some values here. So we plug in 1 here. 1 squared is, of course, 1. Make it negative is negative 1. So e to the negative 1 power, that's going to be 1 over e. And then, of course, e to the 0, when we plug in 0 here, anything to the 0 power is automatically 1. So here's what our expression would be once we plug everything in. Anyhow, yeah, you do all this, and this one we wouldn't keep in terms of pi because it's just going to be a mess. So it's roughly 1.986 for the volume. Okay. I want to show you why we would use one method as opposed to another. So let me show you an example. Okay, so this is going to be the function x squared plus 1. And we're going to go from 0 to 1. And we're going to rotate it about the y-axis. Okay, so it's almost going to create like, if you can visualize it, if it's rotating this way, it's going to create like a bowl that's cut out of a cylinder. You know, not that that's, I don't think you can buy a bowl like that, but if you could, that's kind of what it's going to create. So if you do this with the disk method, because we're doing this around the y-axis, it would be in terms of y. So if we do this with the disk method, right here it would be a solid cylinder, right? And then, then up here it would be based, we'd have to use a washer method. So it would be based on the function. And we would have to rewrite that in terms of y, but that's not an issue. So you see it would be kind of like two different things here. If we were doing this using the disk method, it would be a solid cylinder here, and then it would be like a cutout cylinder. So you'd have to do two different integrals. Now if we're using the shell method, which is what we want to use for this one, because it's in the opposite direction, because it's rotating around the y-axis, we can do this in terms of x. And so it's creating these shells. It's always based on the same function. So this one, you wouldn't have to do this in two parts. You could just do this in one part, and it would actually be very, very easy. So actually, let's try this one out. So we're doing this around the y-axis, which means we do this in terms of x. Volume equals 2 pi. So we're going from 0 to 1 on this function. The radius is just going to be the x. And the height is x squared plus 1 dx. I like this method. It's not too bad. It really depends on what you're trying to integrate. Sometimes one method will work. Sometimes the other method will work. Sometimes they both work. Sometimes neither works. So sometimes, you know, it all just depends. The good thing is in this textbook, everything is sorted by like, it's sorted by what you're working on, so it's not too bad. All right, let's see here. So we're going to go from 0 to 1 of x cubed plus x dx. Let's integrate. 1/4 x to the 4th plus 1/2 x squared from 0 to 1. Okay, when we plug in 1, we get 1/4 plus 1/2. And when we plug in 0, we get minus 0, minus 0, which of course just cancel. So 1/4 plus 1/2, that's going to be 3/4. So 3/4 times 2 pi will be 3/2 pi, or 3 pi over 2. All right. Anyhow, so these ones, I want you to try out these. These ones are going to rotate around the x-axis, which means you'll do them in terms of y. And that'll just be numbers 13 and 15 on, let me write that down, page 437. 13 and 15. All right. We can work on some of these together. If you get stuck, let me know.